Final part of today's notes involves finding sums. When you are finding sums, remember that we have two different types of series. One of which is what we call a finite, which means it ends. There's another type that's called an infinite, and you'll see on the next page we have a separate formula for that. Now, if you do question number 4 and it says to evaluate, remember that that means find the sum. Okay, when there's a sigma there. Evaluate means find the sum if you ever see a sigma. And so that means we need to find the sum of putting in a 1, a 2, a 3, all the way up to a 9 and adding that all up. Now, obviously, you're not going to do that by hand. If you notice, there is an exponential function here. You are going to use these new formulas. When you take the quizzes, you have to look to the right of the sigma. What are we seeing? Is it exponential? Then use the geometric formulas. If it is a linear equation, you're going to use the arithmetic ones. So because this is exponential, you have a new formula you're going to use. Now, when you guys do the delta math, it actually writes the formula this way. I took a screenshot, but basically it's the same thing. Notice that you have this first term, and if you want to use the first formula, in the parentheses, you're going to do 1 minus the r value to the nth power and divide that by 1 minus r. Notice the formula that delta math gives you. They take the a sub 1 and just distribute it to the top two terms, which is equivalent. So when you guys do the delta math, if you see this, don't freak out. It's the same thing that I'm showing you right now. It's the same formula, just written differently. So with that said, if I want to find the sum of n terms, let's figure out what n is first. As review, remember n is when you take the upper number minus the lower number, but we add 1 to it. So if I take 9 minus 1, that's 8, plus 1, I have 9 total terms I'm trying to find the sum of. So S sub 9 equals. Now, in order to find the sum, you first need to find the first term. So the first term here, remember, if it's in the form of an exponential function, this is a sub 1, and this is your common ratio. If you want to confirm, you can even fill in a 1 for n and find that first term by doing 5 times negative 2, and then 1 minus 1 would become 0. Anything to the 0 power becomes 1, and notice you get that first term of 5 that way. Now, in the parentheses, you're going to put in 1 minus r to the nth power. So 1 minus, note your ratio value is negative 2. So I'm going to put that in parentheses, negative 2, and then the n value here we said was this value of 9. Bless you. All over 1 minus the r value. Now, be careful. Sometimes I see people try to simplify this, and when they try to simplify this, they make a giant plus sign in the top because they see 1 minus a negative. But remember, the rules of exponents come first. So you would have to do negative 2 to the 9th power first before you do, my daughter's into the bathroom and I was walking by, before you do the 1 minus. So I'm going to come up to my room. Oh my gosh, my husband's blowing his nose. All right, it's getting loud. Everyone's waking up. So if you are going to do this with a calculator, which obviously you're going to need to, I would highly suggest you listen very closely right now. Oh, there's the delta math that I was getting the screenshot for you guys for one of the problems. So let me, I don't want that though. How do I get my screen? Here we go. So we're going to go here. So what you're going to have to do is in your calculator, you are going to have to do this piece by piece. I always suggest doing this step 1 minus negative 2. You could type it into your calculator or think of this as 1 minus negative 2. That would become 1 plus 2. This becomes a 3. Now, in the numerator, type this into your calculator. Do not make a 1 plus because remember we have to do the exponent first. I think it's easier just to do 1 minus parentheses negative 2, raise that to the 9th power, and you're going to get that answer of 513. Now take that answer, divide it by what you got in the denominator, and then take that answer and multiply it by 5, and that's going to be your sum for 9 terms of this. Now, moving on to question 5, it's the same thing, but before we do question 5, just think about this for a second. If you want to find the total number of terms, remember that we're doing the 20 minus 0, but we add 1. Be very careful here. This is actually 21 terms. You might say, no, it should be 20, but remember the end value at the bottom is normally 1. Now we have to also sub in a 0, so that creates that 21st term. So we have a total of 21 terms. So we're going to find S sub 21. Now we're going to take the first term. Remember, to find the first term, you can sub in that bottom number. But please note that the formula has been rewritten. So when you sub in n equal to 0 here, notice that to find a sub 0, which is really representing our first term here, you would sub in the bottom number of 0, which makes this whole thing equal to 1, which still does give you this first term of a sub 1 being 3. So your first term of this is actually equal to 3, because that's when we sub in the bottom number. That's the value we get. And then we're going to do 1 minus the common ratio. This is always your common ratio, so this would be the 3/2. And then remember, we're going to raise it to the nth power, so 21 all over 1 minus that common ratio. Now, again, like the last problem, do it step by step. Bottom first. If you don't know what this answer is, just find what that answer is using your calculator. Be careful that you get a negative 0.5. Then find the top number second. You may say, Schmear Bear, why aren't you just finding that top number first? Because it's always a very big number, or it's the bigger of the two numbers. It could be very large, it could be very small, it could have a decimal. So I always like to have that stored in my calculator, so then I could divide by the bottom number, which is always a very nice, easy number. It's never like wacky, tobacco. I don't know. Is that the expression? I don't know. Probably not, because it sounds funny. But then we can multiply by 3. So then we get this value of approximately 29,921.311. These numbers get large, because think about when you're multiplying by a value that's greater than 1 each time, the values are going to grow for each term. So you can start seeing some very large numbers because it's exponential. The final question here says to evaluate, but this is written out differently. They actually gave us the series. Oh, let me do a different color. They actually gave us the series here. And so what we need to do is we need to think about, first of all, how many total terms am I adding up? How can I use the formula that we just learned? But what do I know about this series given what I have? So the first thing I'm going to do is kind of walk through and think about this sum formula. I need to know the first term. Well, luckily for us, we have the first term. It's 7. I also need to know what that common ratio is. So if you think about it, what am I multiplying 7 by to get 14 that I multiplied 14 by to get 28? Notice you're getting an R value of 2. So to summarize, we have a sub 1 is 7. We have an R value of 2. The kicker here, though, is how many terms is this? How many times do I multiply by 2 in order to get this 896? And that's where we encounter a problem. Well, that's where you're going to use what we've learned. So if you think about this right here, we want to find out how many times we multiply by 2 to get this 896. Well, let's set up an equation. We want to find how many times we fill in n to get this 896. So let's start filling this out. We have 7 times 2, and we want to think about how many times we're multiplying that 2. So what I can do is I can fill in this formula for finding the rule, but we need to just solve for n. So what I can do here is I could take 896, try that again, divide this by 7. So remember, solving exponential functions here, divide it by 7. So we get that is equal to 128. And then remember from last unit, we want to now rewrite this in log form. So remember, log with a base of 2, and then we have the 128 should equal the n minus 1. So if you have that in your calculator math, you can go to log base, or you can do the change of base formula. So log base, remember that we could put a 2 and a 128, or alternatively, you could be doing log 128 over log 2. But you're getting a value here of 7. But remember, we have to add 1 to that. So our n value is actually equal to 8. And again, this is one of those weird things like, why did I have to put n minus 1 from the beginning? Keep in mind that when I want to get that first term, it needs to be 7. If I don't put n minus 1 and I just put n, then my first term, it wouldn't work for that, because if I fill in a 1, it would give me, if I just had an n there, it would give me a first term of 14, which is not what I want. So that's why that n minus 1 had to be in there. So notice that n would have to equal 8 in order to get that 896. So that means we have 8 total terms here. So our n value is equal to 8. Now, once you have that, you can sub in everything using the formula. So we had to do a little bit of thought process here. Sometimes people just guess and check for this part right here, but I think it's cool to use what we did last unit. So to finish this problem up, we want to find S sub n. So S sub 8. And we have our first term we said was 7. We said the common ratio here was 2. And we want to raise that to the 8th power over 1 minus that common ratio of 2. I always put that in parentheses just to be safe and careful in case there is a negative value there. So as I've done before, find the bottom number first. This one's pretty easy. I'll keep it blue. When you do that, you just get a -1, and then do the top number second. And then obviously divide by the -1, 255, and then multiply by that by 7, and you get this sum of 1785. And that would be your final answer. So clearly there's not a lot of terms to this, and you can see, adding those numbers up, that is where that answer is coming from. Now, the final part of the sum notes, and then there is some practice with the closure at the end, which I will create a third video for. When you guys look at the next set of questions, notice it says how to find the sum of an infinite geometric series. Infinite. One way you'll see this is the infinity symbol with a sigma, or you'll get a problem like number 8 where it goes ... and it keeps going, expressing that as an infinite geometric series. Now, this formula only works when your ratio, the absolute value of it, is less than 1. Because think about it. If I give you something with a ratio that's greater than 1, like for example, if I say 2, 4, 8, 16, and it keeps getting larger and larger, this has a ratio equal to 2. If I said find the sum of an infinite series that looks like this is going to diverge. These numbers are going to keep getting larger and larger and larger and larger, and they don't approach a value. So there would be no infinite sum here. If, however, your ratio is smaller than 1, so like 1/2, for example, if I have 8, then I have 4, then I have 2, then I have 1, then I have a half. Notice that as I keep multiplying by a half, these numbers get smaller and smaller and smaller, and they converge. As you go on, eventually these terms pretty much become 0 and have a very insignificant impact on your overall sum. So as a result, there would be this infinite sum that we can talk about because of that ratio. So just be careful with that. If I gave you a problem, like so for the first example, see how my ratio is equal to 1/2, this will have an infinite sum. If I gave you a ratio that was 3/2, right away you would say there is no infinite sum here because this diverges. So with that being said, you're going to notice this formula is super simple, and you may say, why is this so simple? Well, think about, and even going back up to this problem we just did, any of these right here, think about how if I'm doing an infinite sum, instead of making, and let me use one that actually has a ratio that is smaller. Oh, it doesn't. We don't even have one up here that is smaller than 1/2. But just let's pretend like I'm doing a problem and you have your first term and then you have 1 minus. And let's just say the problem was like this. And then this was to, we wanted to find an infinite sum. So let's just say I put a really large number in here, 100. Think about how this becomes technically a very, 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 very small number. So I'm going to almost say approximately 0 as that gets higher and higher and higher. So really what you have left up on top always, if the exponent is super high, is just a value of 1. Well, if you multiply with that number on top, you just get the 3, which is the first term. That's where this formula comes from. That's why it just is the first term up on top, because basically you're multiplying by what's in the parentheses on top, which technically becomes 1 because that base number, that ratio to a very, very, very large number becomes 0. So that's kind of where this all comes from. So with that being said, if I want to find the sum, you're going to love this. If you want to find the sum of infinitely many terms, you're going to take the first term, which remember is like subbing in a 1 here, which would give us this value of 7. Because keep in mind, if you sub in k equal to 1, because that's the bottom number, you would get 7 times 1/2 to the 1 minus 1, which gives you that starting value of 7, and then over 1 minus the ratio. These problems are awesome. So if you want to use your calculator, feel free to do so. This one's not that bad because really you're getting 1 minus 1/2, which is 1/2, and then 7 divided by 1/2 is like 7 multiplying by 2. You're going to see that you get this sum of 14. So you could do 7 divided by, and then just use parentheses 1 minus, and then 1/2. If you want to use another set of parentheses, you can just to be safe. But you get that value of 14. Which would make sense. You're going to see that as the series goes on, the numbers become so incredibly small that they have no impact on the actual sum. Now, final question from this set is question number 8. It says write in sigma notation and then evaluate. So first thing, let's get our sigma. Remember, you always want that first term to be 1. And then you want, for this one, because of that ... we don't need to find out how many terms this is. I could just put the infinity symbol there. So we have our first term is 9, and then second term is 6, so on and so forth. Now, if you are trying to determine how to write the rule, first thing you want to do is think, am I adding the same value each time to get to the next term, or am I multiplying by the same value? Notice that to go from 9 to 6, I'm subtracting 3, but that same thing does not work for 6 to 4. So this is not arithmetic. You're not going to use any of those formulas. Check now if it's geometric. Now, this is where I was saying that trick works. I don't know what I'm multiplying 9 by to get to 6 or 6 by to get to 4. So the trick is take the second term and divide it by the first. Notice that gives me 6 divided by 9, which if I reduce is 2/3. Now, if I take 9 and multiply by 2/3, notice that gives me 18/3, which reduces to 6. Now check to see if that works. If I take 6 and I multiply it by 2/3, that gives me 12/3, which gives me 4. So notice that it does in fact work, which means this problem is geometric and it has this common ratio of 2/3. So when you write the rule, because it is geometric, you're going to write the first term, the common ratio, and then don't forget to put that n minus 1. Remember that if I just put n, it would say my first term is 18/3 or 6, which it isn't. So I want to make sure that I get a 0 exponent here, so my first term becomes 9. And then from there, we have first part of this. Second part of this is to now evaluate, so actually find the sum. So because it's an infinite sum, we're going to use the formulas you just learned. So we're going to say the sum equals, remember we need the first term over 1 minus that common ratio of 2/3. So if you want to do this in your head, 1 minus 2/3 is 1/3. And when you take 9 and divide it by 1/3, that's like taking 9 and multiplying it by 3. We're going to get this sum of 27. But just to confirm that with your calculator, you can do the 9 divided by, and then use the parentheses, 1 minus the 2/3, and then you will get that answer of 27 as your sum. So I would like for you guys to do the closure questions, and then please watch the third video where I go through the answers